Hi everyone. In this video, we will solve problems based on Kirchhoff laws. These laws are very powerful tools to analyze complex electrical circuits. We will apply Kirchhoff's laws to find the current and voltages. Step by step, you will see how these laws make solving circuit problems systematic and simple. Let's get started. There are two laws, Kirchhoff's current law and Kirchhoff's voltage law. Kirchhoff's current law is also called junction law or the node law. According to this law, sum of all the currents entering the junction is equal to sum of all the currents leaving the junction. Mathematically, we represent like this. Look at a simple problem. This is a junction A. The currents which are entering the junction are I1 and I2. I1 is 2 ampere, I2 is 3 ampere. In this, we have to find how much is I3. I3 very simple. So we can easily calculate. First of all, we have to, who is entering 2 and 3 entering the junction. Entering the junction is equal to leaving the junction. So 2 plus 3, which is equal to 5 ampere, is the current leaving the junction. Yeah, that's it. Now the Kirchhoff's voltage law. It is also called loop law. The statement of this law is the algebraic sum of all the voltages around any closed loop is equal to 0. Mathematically, we represent like this. Here we have to follow some sign conventions, especially two things: sign conventions for the EMFs, the batteries, sign conventions for the resistors. Total 4 are there. 2 for the battery, 2 for the resistor. Okay, sign convention: voltage rise positive, voltage drop negative, voltage rise positive, voltage drop negative. Very simple. Come on, let's focus here. Here, to solve the problem, we can choose the path. Any direction we can take, clockwise direction or anti-clockwise, it's up to us. Suppose we decided to travel in this direction, right side. Okay, so here in our path we found the battery. Suppose we are going in this direction, we are going from low potential of the battery to high, low to high we are moving. In this case, we should take it as the potential rise, voltage rise. Suppose the second case, we are moving in this direction, first high potential to low potential of the battery. So in this case, drop in the potential, that is voltage drop, minus negative we should take. Now let's see the sign conventions for the resistor. Whenever resistor comes, we have to focus on the direction of the current. Suppose the current flowing in the resistor is in this direction. Conventionally, we represent from high potential to low potential. Okay, no need to worry. Just focus on the current direction in the resistor, that is I. Okay, right side. We decided to solve the problem in this direction. So what is the directions here? Current direction and our traverse direction, they are opposite. Whenever opposite direction is there, we should take it as the voltage rise. The voltage across the resistor is the rise, voltage rise, positive voltage. How do you find? Ohm's law, V equal to IR. Next, when we have to take the voltage drop. Okay, suppose we are moving in this direction, right side, the current direction in the resistor also right side, so same direction, then we have to take is as the voltage drop. How to calculate? V equal to IR, so voltage drop negative. So these 4 sign conventions, that's it, we can solve any problem. Let's do a problem. Look at the problem. We have to find the current that is flowing in the 440 ohm resistor R3. So total 3 resistors are given: R1 10 ohm, R2 20 ohm, R3 40 ohm. 3 resistors are given and 2 batteries are given. One battery voltage is 10 volts, another one 20 volts. 2 voltage sources are given. It is connected like this. Okay. Now how to solve this problem? To solve this problem, we have to apply only for this. Okay. So first of all we have to apply the Kirchhoff current law, first law, and then we have to apply the voltage law. So for this circuit, as we can see very clearly, two loops are there, one loop here, one loop here, two loops are there. So we can apply the Kirchhoff voltage law 2 times. Enough. Total with these 3 steps we can solve this problem. Ready? Come on. So before that, okay, KCL, let's apply the Kirchhoff current law. So where at any junction, you can apply at junction A or you can apply at junction B. Okay, observe here. The current is coming from this battery. Assume I1 current is coming here and finally reaches the point A. From here also it is reaching from the battery, second battery, it is reaching the point A. Okay, so at the junction A, two I1 and I2 they are merging, so they are leaving the junction A in this direction. How much current? I1 plus I2, of course, which is equal to I3. We are not using the word I3. I1 plus I2 current is there, is flowing in the resistor R3. Okay, so at the junction A, what is happening? I1 plus I2 equal to I3. This is happening. Okay, that's good. Come on, let's apply the Kirchhoff voltage law in the loop 1. So this is our loop 1. So I am taking the starting point here and I decided to solve this problem first like this, then like this, then in this direction, then come back to the same point in this direction, clockwise direction. I decided to solve. My starting point is this one. Okay, name it as A and B is given here, so I want to call it as CD. So my loop 1 is, I want to start from C, then D, then A, then B, and then come back to A. This is my loop. So whenever we are moving in a loop, CD is one branch, another branch, this is another branch, total 4 branches we can see here. Okay, when we move from C to D, we decided to move like this. So low potential of the battery to high potential of the battery. Whenever battery is there in our path, when we move from low to high, so voltage rise. So we have to take it as positive voltage. So positive plus 10. So plus 10. That's it. After that, we are going in this direction. So we decided to move in this direction. So through the resistance is there in our path. So whenever resistance is there, we have to focus on the current direction. Current direction and our travel direction, the same direction. So whenever same direction is there, it's a voltage drop across this resistor. V equal to IR, voltage drop. We have to take it as the negative voltage drop minus IR, I1 current, the resistance is 10 ohm. Finish. And then so we started from here, then till this much is over. Now A to B. What is happening? A to B. A to B also same direction. So same direction means voltage drop. IR formula. Voltage drop is minus current in AB is I1 plus I2 current. Our resistance is 40 ohms. And lastly, we are coming from B to C. There is no component, so that's it. Oh, finish. So sum of all the voltages rise and fall is equal to 0. Actually over. Let's rewrite this one. Let's rewrite this equation. Come on. How we can simplify it? here 10, this is 40, so minus 50. So overall I can write it as 50 I1, this is, oh sorry, this one also minus 40 I2. I am rewriting this one plus and minus, so I want to write like this way. This is equation number 1. Okay, I am skipping one step. Okay, next let's move on to the loop 2. In the loop 2 I am taking this is as the starting point. Okay, let's mark it ECD. Let's take it as EF. So I want to solve from here. So E to F, then F to A, then A to B, then like this. I am traveling in this direction. This is my loop direction. To solve the problem I have taken anti-clockwise direction. Okay, so what is my loop? My loop is E F A B E. Okay, come on, let's start. When we move from E to F, I got the battery, so negative of the battery to positive, so this is the rise, low to high we are moving, so plus 20, finish. Then F to A, so we are moving in this direction of the current in the resistor. Same direction means voltage drop. How much drop? Minus IR. Formula is I multiplied by R. So 20 I2. And then A to B in the same direction. Okay, again minus I1 plus I2. This is the total current in AB, and the resistance is 40 is equal to 0. Let's rewrite this equation and make it the simple equation. So this time minus 40 I1, then 40 minus 60 I2, and this is 20. Okay, I want to write it because there is no space. When we simplify we get this is equation number 2. Just solve equation 1 and 2 using the calculator. Solve equation 1 and 2 with the calculator. Take your time. So here this is also become positive, I forgot. Okay, 50 40 10. Let's use the calculator. So we have to use this mode, linear equation mode. Okay, first one 50, then 40, then 10. This is my first equation, 50 40 10. Let's write 50 40 10, then 40 60 20, 40 60 20, 40, then 60, then 20. I have entered the values. Then let's find the first I1 is 0.142, 0.142. I1 equal to, I got I1, the negative value we got 0.142 we can take, or we can take 143 also. Okay, because 8 is here. Let's see I2, the second value 0.428 or 429, 0.429, 0.429, 0.429. I2 value is 0.429 ampere. That's it, we got the I1 and I2. Don't worry, sometimes we get the negative answers. Don't worry, it means that whatever the direction here it's given, we assumed or given, it's actually the current is going, it's going in this direction, opposite. That's it, nothing to worry. Okay, what we have to find? We have to find the current which is flowing, the current which is flowing in the resistor 40 ohm. So that is I3. So I3 we have to find. What is the formula for I3? I3 is equal to I1 plus I2. That's it. Come on, you add these two, I1 and I2. How much you get? Use the calculator. minus 0.143, 0.143, then plus 0.429, 0.429. The answer is 0.286, 0.286 ampere. This is the answer. Easy. In the same way, we can do this problem. Determine, this time we have to determine I1 and I2. Okay, that's it. The same, it's looking like the same, only the numbers are different. So same two batteries are given, B1 and B2, two batteries are given, and three resistors, R1, R2 and R3. Okay, first to solve this problem, let's mark it. It's up to you. So let's take it as this is my starting point, this is my loop 1, this is loop 1, this is loop 2. The loop 1 I decided to solve in this direction, clockwise. The loop 2, this is my starting point. Okay, let me mark A, B, C, D. This is my loop 1, A, B, C, D. Let's take it as E, F. Okay, this is my loop 2, E, F, C, D. Again come back to the E. Okay, come on, at point C, at junction C, what is happening? I1 and I2 equal to I3. That's it, nothing to do. Finish. Let's take the loop 1. What is loop 1? A, B, C, D, A. Are you ready? Come on, move from A to B. What is happening? Low potential to high potential. So low to high through the battery, it's positive. So 28. Finish. Then B to C, resistance is there. So we have to look at the current direction. So in the same direction means voltage drop. V equal to IR. V equal to IR minus I1 current multiplied by the resistance is 4 ohms, 4I1. Finish. Come back C to D. Now we are going in this direction, in the same direction in this branch. Same direction means again voltage drop. V equal to IR. So I1 plus I2, the resistance is 2 ohms. So D to A, nothing is there, nothing to write. So we are back to the point A. When we are back to point A, equal to 0. That's it. So rewrite this equation, 28 minus 4I1 minus 2I1 minus 2I2 equal to 0. So if you rewrite 6I1 minus 2I2, so plus, which is equal to 28. This is equation number 1. Come on, let's use the equation. Loop 2, E to F. Okay, what is the loop now? E, first starting from E, F, C, D and back to E. Come on, E to F, what is happening? So voltage rise 7. Then F to C, what is happening? F to C in this direction, current direction same direction in the resistor, so voltage drop. So minus 1 I2 minus again I1 plus C to D, I1 plus I2 multiplied by 2 equal to 0. So 7 minus I2 minus 2I1 minus 2I2 equal to 0. So if you rewrite 2I1 plus 3I2 is equal to 7. This is equation number 2. Solve it. 6 to 28. 6 to 28. 6 to 28. Okay. Let's take the mode. 6 to 28. Finish the first equation. Second equation, 237. 2, 3, 7. That's it, we are ready. So first answer is 5, the second answer is -1. 5 and -1, 5 and -1. So first answer is 5 ampere, second answer is -1 ampere. Don't worry, -1 means whatever the direction we have taken, we have to reverse it. That's it. I hope you understood. Thank you very much.